Welcome to the hands-on session on sequential data types that are supported by Python. In the last video, we have seen various scalar data types that are supported by Python. Python supports 4 different data types to store scalar data values. So it supports int, float, complex and bool data types to store a single or elementary type of data. But whenever we'd like to store collection of elements, it is not possible to store that collection of elements using these scalar data types. In addition to these scalar data types, Python also supports a set of collection data types which supports the storage of collection of elements. So to store collection of data, Python supports list, tuple, string, dictionary, set and frozen set. In this video, we'll see various sequential data structures that are supported by Python. So Python supports list, tuple and string to store the data in sequential manner. As there is an order among the elements that are stored in these data types, so these data structures are known as the sequential data types. We'll see all these data types in detail in this video. Consider these variables A, B, C, D and E. So here A is of int type, B is of float type, C is of string type and D is of complex type, where E is of type Boolean. These data types are known as the scalar data types as we are able to store one and only one value. So here one integer, one float value, one string, one complex number, one Boolean value we are able to store. It is not possible to store more than one value using these data type variables. So when we would like to store a collection of elements, these scalar data types do not support. Then the solution is usage of the collection elements. So we'll see now in this video various sequential data types that are supported by Python. We'll start our discussion with list data type first. So here you can see L equal to 10, 20, 30, 40, 50. So a collection of integers I am storing in this variable L. So here whenever you would like to create a list, so the list of elements must be enclosed in these kind of square braces. So then the variable is created as a list. Here you can see L is a collection of elements. It's not a single value, it's a collection of elements. So that's why this list is belonging to the collection data type. That is how you can store a collection of elements into a single variable. In the variable L, I have stored a collection of integers. So it need not to be the integers alone, you can store other types of data also. Here if you observe L1 equal to a collection of strings. So where I am storing a collection of strings to the variable L1. So here you can see L1 is a collection of strings. So that is how you can store collection of elements using the list data type. So it need not to be of homogeneous types. In the case of the L, so I am storing a collection of integers. In case of L1, I have stored a collection of strings. It need not to be homogeneous. It is also possible to store a collection of heterogeneous elements. Here if you observe this example L2 where I am storing a collection of different types of values. So I am storing an integer value, a string, then a float type of value and another string. So that is how a list also supports storing a collection of heterogeneous elements if you want, or if you want you can store the homogeneous elements also. If you would like to check the type of the variable L, you can use the type method. You can see, so list is the class. So L1, L2, these variables are belonging to the list type. So that is how list data structure allows us to store a collection of elements where the collection of elements could be of homogeneous type or could be of heterogeneous type, similar to the case of L2. We have seen how to create a list with collection of integers, collection of strings and collection of heterogeneous elements. So this is how we can create the collection of non-empty list. Now let's see how we can create the empty list where you are creating a list without any elements. There are two possibilities of creating an empty list. So one way is to assign empty square brackets to a variable to create an empty list. So here L is the variable which is assigned with the empty square braces where L is created as a list though there are no elements in that list. The other way to create an empty list is by assigning the variable with the list constructor. So here if you observe L equal to list without passing any arguments. So in this case also L is treated as an empty list though there are no elements, it is treated as a list. That is how it is possible to create empty list. In this case we have created L as an empty list and in the other cases L1, L2, L3 they are created as non-empty lists. So far we have seen the creation of non-empty list and the empty list. So now let's see once the list is created how do we access the elements from the list. As lists are the sequential data structures, they preserve the order of elements. That is you can use the integer index to access any specific element. So here I can use the index 0 to access the first element from the list EL1. And I can use the index 1 to access the second element from the list EL1. So that is how you can use the index to access any specific element from a specific list. So use the list name followed by the integer index. So 0 is to access the first element, and similarly you can use the index 1 to access the second element from the list, and similarly to access the third element use the index 2. So on and so forth, you can access the last element also. Here the list L1 contains 5 different elements. So to access the last element, use the integer index 4. So this is how I can access the first element using the index 0 and the last element using the index, the number of elements minus 1. So here L1 contains 5 elements, so use 5 minus 1 as the index to access the last element. So this is how we can use the positive index to access a specific element from the list. Even you can access the negative indexing. So say for example, I would like to access the last element from the list, and I don't know how many elements are there in the list. Without knowing any knowledge about the number of elements, it is possible to access the last element by using the negative indexing, so minus 1. So L1 of minus 1, which allows you to access the last element from the list. And similarly, if you use minus 2, you can access the last but one element. This element can be accessed by using minus 2 as the index, so on and so forth. That is, if you use the negative indexing, the last element can be accessed using the minus 1 as index then. So this one minus 2, minus 3, minus 4, so on and so forth. So this is minus n, where n is the number of elements. So that is how a specific element can be accessed from a list either by using the positive index or by using the negative index. Say for example, I am accessing the first element from the list EL1 because there are 5 elements. So it shall be accessed with the help of minus 5 as index. See, so from L1 I am using the index minus 5, so I am able to access the first element from L1. It is also possible to access multiple elements using the slicing operator. So basically Python provides a specific slicing operator which allows you to access multiple elements from the list. Say for example, here in this case there are 5 elements in the list L1 and I would like to access portion of elements from the list L1, that is 20, 30, 40. So let's see how we can access that. So if you observe 20, 30, 40, so their indices are 1, 2, 3. So that is how you need to use the starting index as 1 and end index as, so 20 with the index 1, 30 with the index 2, 40 with the index 3. So that is how you need to pass 4 as index, L1 of 1:4. This is how you can access multiple elements from the list using the slicing operator. So to know more about the slicing operator, you watch a separate video. So that is dedicatedly designed for the slicing operator. So thereby you will get more understanding about the slicing operator. So you can even access the list of elements in the reverse order by using the slicing operator and by passing the step counter as -1. Here you can see, so from the list I am accessing the elements in the reverse order. So this is how you can access a single element or a portion of elements or even the elements with a step counter. It is possible to access elements from the list. So far we have seen few details about the list data structure. So basically in Python, list is created as a mutable data structure. So the reason for calling this data structure as mutable data structure is it is possible to add a new element to the list. Say for example, when I call this method append and if I pass an element to the append method, so then a new element is added to the list L1. So now see, so L1 is the list with an element appended at the end. So that is how it is possible to add new elements, to remove existing elements from the list, or even you can update the elements of the list. Say for example, I am going to update the element at the index 0 to 500. Now if you observe in L1, the first element is updated with the value 500. So that is how it is valid to do any updates to the list data structure. So that is how list data structure is known as a mutable data structure. So in Python, we have another sequential data structure with the name tuple, which is an immutable data structure where updations are not valid. So now let's see how a tuple data structure can be created. An empty tuple can be created by assigning an empty parenthesis to a variable. Here if you observe, t is a tuple of course, but it is having no elements. If you would like to check the type of the variable t, then you can use the type method. So here you can observe T is a tuple. An empty tuple can also be created by using the tuple constructor. So in this case also T is created as an empty tuple. So now let's see how a tuple with non-empty elements can be created. So here if you observe, T1 is a collection of elements where it is created with a collection of integers 10, 20, 30, 40 and 50. So you can create a tuple with a heterogeneous collection of elements also. If you observe, in the case of T2, it contains heterogeneous collection of elements. So integers, float type of data and also string type of data are used as elements of the tuple T2. So you can see T3 is created as a tuple with a collection of strings. So that is how it is possible to create the tuples with the heterogeneous elements or with homogeneous elements as collection of elements. So if you observe, you can use a type method to check the type of the tuple variables. You can see T1, T2, T3 all are belonging to the class tuple, indicating that they are the tuple variables. So now once you create the tuple variable, so let's see how we can access the tuple elements. So similar to the list, tuple is also a sequential data structure where the ordering of elements is preserved. So you can see 10 is the first element, 20 is the second element, 30 is the third element, so on and so forth, 50 is the last element. So that is how the order is preserved in case of the tuples also, similar to the list. That is how it is possible to use an integer as an index to access a specific element. You can use 0 as the index to access the first element from the tuple, and similarly you can use 1 as index to access the second element and so on and so forth. Whereas the last element of the tuple can be accessed by passing the number of elements minus 1 as an index. Here in this case 4 is used as an index to access the last element from the tuple T1. So that T1 of 4 returns the last element from the tuple. So in these cases we have used the positive index. It is also valid to use the negative indexing to access a specific element from the tuple. So here if you observe, the last element of the tuple can be accessed by using minus 1 as an index. You can even use the slicing operator to access a specific portion of the elements from the tuple. The accessing of elements is exactly how we did in case of the list. There is no change at all. You can even use the step counter in case of the tuple also. The only difference between the list and tuple is, so list is a mutable data structure where it is possible to update the elements of the list. But in case of the tuple, it is not valid to update the elements. So that is how tuples are immutable data structures. So there are no methods that are allowed to update the elements of the tuple. That is how they are immutable data types. So more details on these data structures will be provided in the second module of this course. String is another sequential data structure that is provided by Python. Here you can see in Python, so strings can be created in different ways. Either whatever the content that is enclosed in double quotes or single quotes or triple quotes, so those values are treated as strings in Python. Here the string is enclosed in double quotes, here single quotes are used, here triple quotes are used. You need to remember one point, like there is no separate char data type that is provided by Python. So even the string contains single character also, it is treated as a string. So you can check the type by passing the variable name to the type method. Here you can observe S1, S2, S3 all are belonging to the string class. So even if the string contains a single character also, that is also treated as a string only. It's not treated as a character in Python. There is no character data type in Python. So as the string is also a sequential data structure, you can use the integer indexing to access a specific character or portion of characters from the strings. So consider the string S1 which contains the string Python. So here you can use the index 0 to access the first character from the string. Similarly, you can use the -1 to access the last character from the string. So that is how you can use the integer indexing to access any specific character from the string. Either you can use the positive indexing or you can use the negative indexing to access a specific character. So the indexing is exactly same as how we did in case of the lists or tuples. So even we can use the slicing operator to access specific portion of the string. So that is how indexing operators can be used to access strings. So you can use the operators also. Plus operator can be used to concatenate two strings. So here we have seen S1 is Python and S2 is also Python. So when I apply S1 plus S2, you can observe Python is concatenated with Python. So the strings that are available in S1 and S2 both are concatenated together and is returned by using this operator plus. and we can use the asterisk operator to repeat a specific string. Say for example S1 asterisk symbol 3. That means the string in S1 is repeated for 3 times. So you can see the string in S1 is Python, and that Python is repeated for thrice as we are using this asterisk symbol with the value 3. So the string is repeated for 3 times. So that is how this asterisk symbol can be used to repeat the string for a specific number of times. And you can even understand these operators can be used with the lists also. These plus and asterisk operators can also be used with the lists and tuples. Let L1 is the list and L2 is another list. When you apply the plus operator on L1 and L2, then it returns the concatenated list, which is a concatenation of L1 and L2. Similarly, you can apply the asterisk operator with the list. So for repeating a specific list for a specified number of times. So here L1 asterisk 3, this operation returns this list L1 for 3 times. Similarly, you can apply the plus operator on the tuples to concatenate 2 or more tuples. Here T1 and T2 are concatenated together using the plus operator, and in this operation asterisk symbol is used to repeat the tuple T1 for 3 times, whereas in this statement, so the tuple T2 is repeated for 4 times. So that is how various operators can be used with the sequential data structures like lists, tuples and the strings. So far in this lecture we have seen various sequential data structures where you can store a collection of elements, but there is an ordering among the elements that is provided. In the next video we will see some of the other collection data structures like dictionaries and sets. Thank you for watching this video.